In this video, I'm going to look at solving polynomial inequalities. So in the previous video, I looked at solving linear inequalities. Now we're going to go to polynomial inequalities. We're going to start with sort of the simplest polynomial above a linear, which would be a quadratic. So we want to solve the polynomial equation x squared minus x minus 2 bigger than or equal to 0. So we want to figure out which x values make this thing here positive or bigger than 0. I would suggest it's probably not surprising that your first step is going to be to factor, just like it was if we wanted to solve an equation, right? If you want to solve a quadratic equation, you factor. So if you solve a polynomial inequality, you factor. So we're going to factor the left side of this inequality, and you need to think of numbers that multiply to -2 and add to -1. So the numbers there would be -2 and +1. Okay, so now we have sort of two linear factors being multiplied to give us a number bigger than 0. So there's a couple ways we could do this. What I'm going to do is think about the graph which corresponds to this. So let's let p at x equal this quadratic. So I'll put it in factored form, x plus 1, x minus 2. So just to do a very quick sketch of what that graph looks like, well, we know it's a quadratic, so it's a parabola. We'll have x-intercepts at -1, right? If we were to set this equal to 0, x plus 1 would equal 0, and x minus 2 would equal 0, meaning x would equal 2, and x would equal -1. So your x-intercepts are -1 and 2. And we know that it's a parabola facing up because the leading coefficient is positive. So now we want to, so if you go back to this one, we want to know when is this bigger than 0, which really means when is it positive, when is it above the x-axis, right? These are positive values of f at x, right? These are negative values, these are positive. So when is this above? Well, over here it's positive, and over here it's positive. In the middle here, it's below the x-axis, so it's negative. Here we're above, here we're above. So anywhere here we're above, anywhere here we're above. So from the graph, we can see that x plus 1, x minus 2 is, bigger than 0 if x is in which intervals. So the first interval would be here all the way up to this point, -1. So from -infinity to -1, right? We're positive on this interval. Or from 2 to infinity. So wherever it's above the x-axis. Okay, so that is one way. So that would, well, that's one way to solve this inequality, right? That's the inequality to this, or that's the solution to this inequality here. So that was by graphing. This is a good way to do it for quadratics, right? Because quadratics we can sketch very, very quickly. If it's a cubic or higher, it might be a little bit more challenging, because if you remember, sketching a cubic is not the easiest thing. Sketching a quartic, even more not easy. So another way to do this is what I would call, or what I'll say is making a chart. And what we do when we make a chart is we just think about the two factors here, and the fact that these factors multiply to give us a positive number. So if you're multiplying two numbers and you get a positive number, that means that both these factors must be positive, right? Because a positive times a positive is equal to a positive, or they must both be negative, because a negative times a negative is equal to a positive, so it's bigger than 0. If one of these was positive and one of these was negative, you'd have a positive times a negative, which is negative, which is not bigger than 0. So you're going to have to find out which values of x make both of these things positive. So what we're going to do is we're going to set up a chart as follows. Along the top, we're going to put intervals, and these intervals are going to correspond to when these two factors would be 0. So these two factors are 0, we'd already figured this out, at negative 1 and 2. So we're going to go from negative infinity to negative 1, from negative 1 to 2, and from 2 all the way to infinity. Okay. So your intervals basically cover the entire real number line, and you're going to break up these intervals where this thing would be 0. Okay. Now along the right side, you're going to write the factors, x plus 1 and x minus 2. Now in the middle of your chart, or in the body of your chart, you're just going to figure out, are these factors positive or negative in this interval? So you're going to pick a number in this interval, any number, negative infinity to negative 1. So let's say negative 3. Right? Any number in between negative infinity and negative 1. So if I pick negative 3 and I put it into this linear factor, negative 3 plus 1, I would get a negative number. Right? Negative 3 plus 1 is negative 2, so that's negative. And I only care about the sign. If I put negative 3 into this factor, negative 3 minus 2, that's again a negative number. So I get negative, negative. In this, now I'm going to do the same for this. Pick a number between negative 2 and 0, or negative 1 and 2. Well, then easy one is 0, right? 0 is in this interval. If I put 0 into this factor, I'd get a positive number. 0 plus 1 is positive. 0 minus 2, that's negative. And now pick a number in this interval between 2 and infinity. Let's say 10. So 10 plus 1, positive. 10 minus 2, positive. Now here you're going to think about the product, x plus 1, x minus 2. So if I multiply x plus 1 times x minus 2, I'd be multiplying a negative number times a negative number, which is a positive number. Here, a positive number times a negative number, which is a negative number. A positive times positive, a positive. So now you go back to what inequality are you looking at? We're looking at bigger than 0, meaning positive, right? We want to find out when is the product positive. So that would be this one and this one, meaning these are the intervals from negative infinity to negative 1 and from 2 to infinity, which is the exact same intervals we got over here. So from the chart, we get, therefore, x is an element of negative infinity to negative 1, union, or 2 to infinity. So you get the same solution set. It's just another way to do it. It's more of an algebraic way where you're not thinking about the graph. So the advantage here is you don't have to graph it. The disadvantage is it's not as visual. But the advantage of not graphing it is when you're doing a cubic or something like that, it might be easier to not graph it. Although you might find it just as easy to graph it.